Hi folks, we're going to take a look at page 348, number 3. So here they're giving us two vectors, x and y, and they're giving us that the magnitudes of both these vectors is 3, and they're also giving us the magnitude of the sum. Okay, and what they're asking us to find is the magnitude of the difference. Okay, so let's start with what we're looking for, and what we're looking for is the magnitude of the difference, so we know we're going to place those vectors tail to tail in order to determine the difference. Okay, so say this is vector x. Okay, and here's vector y. And I'm looking for the magnitude of the vector that goes of x minus y. Now, of course, since I'm only looking for the magnitude, and we know that that's the vector that joins the two tips, it doesn't really matter in what direction we go, but we should try to draw it in the correct order. So here we go, remember, for subtraction, tip of the second to the tip of the first. So this is the vector for which we want to find the magnitude. Now, I know that the magnitude of x is 3 and that the magnitude of y is 3, but I don't have enough information to solve yet. I would need an angle, and likely the angle between them. So this is where we have to bring in the other information that's given, which is the sum. Now, I can do this on a separate diagram, or I can do it on this one here. We know that the sum is given by putting those vectors tip to tail. Okay, so this again will be magnitude 3, and this is the magnitude of 17, their sum. And what we see that we can do is we can determine this angle. Okay, let's call it angle phi. And we know that this angle is supplementary to the angle between them. Okay, so we'll call that one theta. All right, so we're using the knowledge we have about the sum of the two angles to indirectly get the angle between the vectors. All right, so let's calculate that. So let's first calculate this angle here. So phi is going to be equal to cos inverse of, so its opposite side is root 17, so root 17 squared is 17 minus 3 squared minus 3 squared all over negative 2 times 3 times 3. Now I'd go straight to the answer for the angle, but if you want to rewrite the cosine law in its usual form and then solve, you can do that too, of course. All right, so let's calculate that. Make sure your calculator's in degrees. Okay, so cos inverse of, and here I'm going to be careful with my brackets, so 17 minus 9 minus 9, close brackets divided by, open brackets again, negative 2 times 3 times 3, and we get 86.8. Okay. Okay, but of course this is not the angle that I'm going to use to solve the problem I need to solve. I'm going to be using angle theta, which is 180 minus 86.8. And so I'll just subtract 180 from there, and we get 93.2. Okay, now notice here that it turns out my diagram wasn't accurate. Turns out that this angle was actually obtuse and this one here was acute, but it doesn't matter because remember, I'm just using this diagram as a guide. Okay, so now that I have these two side lengths and the angle opposite the magnitude that I'm looking for, which is the magnitude of x minus y, I can now use the cosine log in. Okay, so here the magnitude of x minus y is just going to be given by the square root of sum of the square of the other two sides, so 3 squared plus 3 squared minus 2 times those two side lengths times the cosine of the angle between them, which now we know is 93.2. Okay, and so let's get an approximation for that. So square root of 9 plus 9 minus 2 times 3 times 3 times cosine of 93.2, and looks like we get about 4.36. All right, so there you have it. So again, this is one of those examples where by understanding the relationships between vectors when we're adding or subtracting them, understanding the differences in the angles and how they relate to the vectors, we're able to set up a diagram that allows us to use trigonometry to solve all these things. Okay, that's it for this one.